Sir, I'm fine, sir. Actually, I was not there, sir, in the last class, like only half hour I did.
Yeah, so you didn't join in the last class, right? So,
Sir, only half hour I attended, then I got disconnected.
okay, so, so I will, so we will take a backup class, right? And then in that backup class, I will cover what detail, whatever you have. Okay, Chavez.
Okay, sir.
So up to what point you were with, so when did you disconnect?
So that charges, you can see that problems after that I got disconnected.
Okay. Okay, so okay, I will repeat that for you. Okay, I will arrange some extra class, and in that class, we will repeat that. Okay, yeah. So yes, so very simple, very few simple revision. That first is that we know about the electric field of the point charge, right? So electric field of the point charge, that is how much? Let's say you have this point charge, right? Let's say this is Q and you are calculating the field at this point. Let's say this is some field point P. So this separation is R. So what is the electric field? Magnitude of this electric field? This is simply KQ by R square. Right, guys? Right, guys. And if let's say, yeah. And let's say if we are, so I'm revising whatever, just quickly revising whatever Amna ma'am did in your CPC. Okay. So let's say you are sitting at the, so let's say that the charge is sitting at the origin. And this is the x-axis. So you are measuring the electric field in this x-axis, and this separation is x. Right. So let's say that this charge is at the origin, and you are calculating at this point. So your electric field, the magnitude of this electric field would be simply KQ by x square. Right, guys? Let's say this is some positive charge. Okay. So if you want to plot the variation of this, if you want to plot this variation of this electric field, so that would be like this. This you already learned in your CBSE test, right? Right, guys?
Yes, sir, can you repeat?
Yeah. So this is the x direction and this is the electric field. So this would be the variation of the electric field with the x-axis, right? So this you already know, right? For the positive charge. So you want me to explain this figure or you already did this part? Yes, anybody. So if anybody has any doubt, I can repeat that. This figure. How do we get this figure? Yes.
Sir, down part, can you explain like down how?
Yeah, could you please? Yes. So let's say that we know that this is the magnitude, right? So this is KQ by x square, right? So let's say, let's calculate this value at the origin. So at the origin, the value of x is 0, right? So something by 0 is how much, guys? So something by 0 is undefined, infinity, right? So this will come at this point. And when we are increasing, so when we are increasing this value, right, we are increasing the denominator, right? So let's say this is something constant. So these are some constant values. And we are increasing the denominator. Let's say this is 1. Let's say this is 4. This is, let's say, 9. And we are increasing this value. So let's say this is 100. And let's say this is again 10,000 or so. So you will see that these values are decreasing. So this value is 0.00005. So this is closing to 0. So let's say I move to infinity, right? So this electric field will decrease and then goes to then go to zero. So this point represents that electric field is zero, right? On the y-axis, we have electric field. So this point shows that this will reach to zero. Okay, so this part is this part clear, everyone?
Yes, sir.
And what about this part? So yes. And so this part, you know that this, whenever you put the x value to be negative, so the square would be positive. So it should come like this way, right? So it should be in this way, right? But when you measure from this negative direction, right? So the electric field will be in which direction? So the direction of the electric field will be in this direction. Okay, so this will be in the negative direction. So that's why the field variation would be like this. So this will go to minus infinity, right? And when you
Yes,
go
sir.
to minus, so when you go to minus infinity, then this will reach to zero. Okay. So clear, everybody?
Yes, sir.
Yes, Faiza and Madira and all. Clear? Yes. Okay. So this is due to a point charge, and we consider the charge to be positive. But for the case of this, so for the case of this negative charge, the variation of this electric field will be this. So this would be the variation. Okay, guys, understood. This is minus q sitting there, and this is xx, and this is electric. Okay, guys, understood.
Yes, sir.
Yeah. So yes, yes. Okay, so now so we calculated the electric field due to point charge, which came out to be r square. Right. Then you have this superposition principle. So in superposition principle of electric field, just like the force, so you have this
Vector,
electric
sir.
field, yeah, vector sum, right? So vector sum E1 plus E2 plus E3 and so on. Right, guys? So let's say what would be the effective or the diagram, respective diagram of that. So let's say this is Q1, this is Q2, this is Q3, and let's say this is Q1. So we are calculating at this point, and this distance is R1, right? So this would be KQ and let's say R1 square and then R hat, right? And this would be KQ2 by R2 square and then R1 hat, R2 hat and something like this, right? KQN by Rn square and then Rn. Okay, so this is about the superposition principle of electric, right? And then you have this electric field due to dipole, right? So you already learned this, that we can calculate the electric field of the dipole in two places. So one would be at this line, right? This is the axial line. And let's say at this point you calculate from this value, this is R. Okay. And let's say you calculate at this point. So I'm just revising whatever you guys have done, right? So let's say you are calculating at this point. So this is the equatorial. Let's say this distance is R. So there will be two parts. One would be E axial, right? E axial would be how much? Do you guys remember? The dipole moment is P hat, which is Q into D, right? And let's say this is P hat direction. So what is E axial? Chavez, do you remember? Tariq.
Sir, I did derivation, but I have to revise.
Yeah, so whatever formula you came across, just write it in some separate copy, right? And make only the notes of those formula, right? And daily repeat those formula. Okay.
Sir, is it
So
2P by R cube?
yeah, yes, 2 kp by pi. Yes. So this axial field varies as 1 over r, right? And then you have this, yes, correct. Tarek. And then you have this equatorial, right?
KP by RK.
Yes. So this is minus kp by pi. Okay, this also varies with 1 over r. Right, so this is about the electric field of the diagram. And then you have this, so what I will do is that I will calculate the electric field due to this ring charge. Okay, at this axial point. So let's say this axial point is somehow. Yes, sorry about that. Yes, so what I was saying, yeah. So we need to calculate the electric field. The radius of this ring is, let's say, okay. And let me write this as. So we will calculate the electric field due to this. So do you guys remember this? What is the electric field due to this ring charge? Do you guys remember? Tarif is saying that Amna ma'am did this electric field. Okay, then what I will do is that I will derive the electric field of this finite length line charge. Right, this is theta2 and this is theta. Okay, so what is the electric field? So you have two components: electric field in the x direction and electric field in the y direction. Okay, and then I will do, then I will calculate the electric field of the upper half part. Right. What is the electric field of this? So this, you know that this will be Ex and this will be Ey. Okay, and then we will calculate. So then I'll just write what is the electric field of this disk, not this disk, but this semicircular ring. Okay. So this will be on Ex. And what is the electric field due to this quadrant? So these formula you guys have to remember. Just write down somewhere and just so this is Ex and this is. Okay, guys. So I hope that today in today's lecture, okay. So I will not do the derivation of these. This is some disk, right? So electric field, we do this. Okay. So I will not do the derivation of this part, but others I will explain. Okay, guys. So this, yeah, so this will come out to be what? Sigma by Q epsilon naught 1 minus x upon x squared plus r. Right. This will come out to be lambda by Q by epsilon naught r. Right. And this is I hat. So those are C. So we will see how we can get this. Okay. Yeah. So let us calculate the electric field due to this ring charge. Okay. So the all these things we are calculating from this small charge Q, right? We are not using the Gauss law. Okay. So when we will be doing the Gauss law, then we'll apply those Gauss law. Okay, guys. Yes. Yes, so first let us calculate the electric field. And whenever you guys have any question, please do not hesitate to ask. Okay. Electric charge, electric field, due to wind charge. Okay, so this is some wind, right? And there is this small charge element dq. This is the radius of this ring. And we are calculating the electric field at this point. Okay. So you guys know that, let's say that it makes some theta angle with this line. And this distance is x. Okay. So you guys know that this y portion will get cancelled out due to this point, right? And only this portion will survive, right? So the electric field would be dE cos theta, right? This is x. Okay, guys. So and what is this dE? So this dE is due to this small charge dq. Okay, so how much would be this d? This would be k, and this dq by what is this distance? So what is this distance, Chavez? What is this distance?
dx, sorry, x.
So this is x.
Okay,
This
okay.
is right. So this would be
Root of x plus a square.
right. So this is the separation. And yes, so Faiza, what is the electric field due to this separation? So let's say this is some point charge. So here this would be separation square, right? Right, Faiza? Okay, yeah, you can write it in chat. Yeah. So this would
Sir,
be yes.
Sir, can you explain how did y component got cancelled?
Yeah. So you see that let's say this is theta, right? And you have this dq over here. Okay. The same dq which was here, so same dq here. So this will make another angle which is theta. Right. So this is theta. This is cos theta, right? And
Yes,
this is sine theta. Right. Again, for this theta, we have this dE cos theta. And this is dE sine theta. So you see that EY cancels. Right.
yes, sir.
Only this cos theta will survive. Okay. And when we do this whole integral, then we have not written this 2 factor here, right? Because we will do the whole integral of this. Okay.
Sir.
Yes. Yes, Chavez, any question?
No, sir.
Yeah. So this is k dq, and separation is how much? This is x square plus a square and then off square. Right. So this would be k dq and x square plus a square. Right. So we can write this ex. So let's say this is small element dx. Okay. So this is dx is, this is k dq by x square plus a square. Right. And we see that this, oh, what about it? We see that what is cos theta here? So let us draw this triangle. This is theta, right? This is base, which is how much? X. And this is the hypotenuse. Okay, guys. So we can write the value of cos theta from here. So cos theta is B by H. Okay, guys. So this would be X and root of X square plus A square. Right. So this is 1, this is half. So the power will add and we will get how much? So this is kx dq and this is x square plus a square power 1 plus half, which is 3 by 2. Right. This is dx. Now we can integrate the thing with the right. So you can see that this dq doesn't depend upon this x and a. So this we can take out. So only the integral of dq will survive. Right. So ex would be kx divided by this x square plus a square 3 by 2 and dq integral is q. Okay, guys. Any doubt in this part?
No, sir.
So this is the electric field due to this ring charge. Okay, so I will put the screen and then you guys please make it stop. Yes, anybody, please, if you guys have any question, you can ask. Right. Don't keep your doubt to yourself. Okay.
Yes, sir.
Yeah, because this is my job, right? So I have to justify my job, and if you guys keep your doubt within yourself, then I'll do injustice to my job, right? So please ask me questions. Yeah, and only Tarif has sent me his homework. You guys always forget. So whenever I give some homework, you guys don't give back the answers or solutions to the homework. Right? Yes. D, where is this D? Where is D?
Sir, in the final formula, we just wrote dx equal to kx q by x square plus a square 3 by 2.
Right. So we didn't. Oh, so this is integral. So this is operator. Tarif sir, this is operator. dq is some small. So this is the differential operator, right? Small change in this dq. So whenever okay, sorry that I didn't write this integral here. Okay. So when you integrate this dq, right? So we get q. Understood, Tarif?
Yes, sir.
Yeah, sorry that I didn't. So I just imagined. Yeah, so this is the integral.
Sir, here all of the constants will be out and only q will be integrated.
Yes. So yes,
Yeah.
Chavez.
Here all of the constants will be out and q will be integrated, right?
Yeah. Because this q doesn't depend on any of these factors, right? So that's why we can take it out and only the dq integral will survive. So this is how you will get this q. Okay, so everybody noted.
No, sir. I'm doing.
Yeah, so whenever you guys are finished noting. Yes, Mamiya Faiza, any doubt? So yeah. Done. Yes. So whenever you guys finish noting, please. And please always write those formula in some notebook, right? Then whenever your entrance or whenever your exam happens, so you can go through those shortened notes, right? You don't need to see all those derivations. So what should I say? So paste or so make some sticky notes and paste those formula on the walls, right? And just look at those walls always. Whenever you guys go to sleep, so just look at it. Okay. Yeah, we left. Chavez got disconnected. Yes, everybody noted. Faiza has noted, Madhya, Ari, and Chavez was here, but he got disconnected. So yes, Sarif and Madhya done noting.
Yes, noted.
Yes, Madhya, you said noted, but what did you say? Okay, I will. So just write it in the chat box. If your mic is not working, so just write it in the chat box. Right? Yeah. So then the next thing is that what would be the variation of this electric field, right? For this ring charge. Okay. So for this ring charge, this is the variation. So first it increases, then it decreases. So this is first it increases and then it decreases. Okay, so this is the variation of so this is X and this is E. Okay, guys. So now, yeah. Yes, Shavit sir. Did you able to note down all the part that you were noting?
Sir, can you explain
Yes.
the graph?
Yeah. So firstly, to explain the graph, I need to explain this maxima, right? So you
Sir,
have this.
disconnected.
You didn't
Yes,
you
sir.
didn't note it. So did you note down, or you were not able to note down? So did you able to note down what you were noting, Chavez?
Yes, sir. I took a screenshot.
Okay, then. Yeah, so then we are plotting this variation of this electric field. So we are plotting this variation of this electric field due to this ring charge, right? So you have this. So this you have the electric field is proportional to this X divided by this X square plus A square divided by power 3 by 2, right? So when your X is small, right? When your X is small, so E is directly proportional to X, straight line. Understood, Tariq and Chavez and
Yes, sir.
So then it will vary like this. Similarly, in this direction also. But when this, when this X increases, so then this term dominates. So this will vary like this. Okay. Understood. So then this will
Yes, sir.
vary as 1 over X square plus B square V by 1. Right. And when you go this A square, so this would be X cube. Right. So this is how it will vary. Okay.
Yes, sir.
Yeah. So then the important point is that what is this point? What is this X point, which is max? Right. This is also some X, which is not, let's say it's right. And what is this max? And what is this Right. So this we need to find. Okay, guys.
Sir.
Yeah. So how? Okay. So let me ask you, how do we find the maxima and the minima, guys?
Sir, we differentiate and
Yeah, and equate it to C. Right.
yes, so that
Correct.
double differentiation.
Yeah. So so where we check the maxima or minima for the second derivative, right? If your second derivative is greater than 0, so that is minima, and if your second derivative is less than 0, so that is maxima, right? So
Sir.
we check, yeah. So to check the maxima and minima, we do the second derivative, but we are only calculating the maximum and minimum value. So the first derivative will give you this point, right? Right, Chavez and
Yes, sir.
yeah. So we need to find the first derivative of, and what is the respective function, or what is the respective variable that we need to take the differentiation. So with respect to whom we need to calculate the differentiation,
X.
right? Because in some question, in the previous question, we calculated this force with respect to this Q, right? When we wanted to calculate the maximum and minimum charge. So we did this first derivative with respect to Q, so df by dt. But we are varying with this x, so we need to take the derivative with respect to x. So dt by dx we need to calculate and put it to 0, so that this will give us the value of x. Right, so clear everybody?
Yes, sir.
Yeah. So again, I will repeat that many times. If you guys have any question, any doubt, so please, because Chavez and Tariq always ask that, right? And Faiza, if you don't feel that you are not comfortable with the mic, so please ask in the chat box, right? Then I will explain. Okay, Faiza and Madiha to you also. So please don't keep any doubt with yours. Okay. Yes. So we need to find this d by dx, and E is how much? E is kqx by this big number, which is c by d. Right. So dE by dx would be, this would be k, and which property we need to use? Right,
U
guys?
dash V minus U dash.
Yeah. So kq u dash v minus u v dash divided by v square. Right? Do you guys remember this formula?
Sir.
The quotient rule, right? So u is how much? So u is x, v is x square plus a square 3 by 2. So let us also calculate this u dash. So u dash is 1, v dash is 3 by 2, x square plus a square 3 by 2 minus 1 is what? 3 by 2 minus 1 is half, and then into what? Sorry. Yes. Into would be what, Tariq? Do you remember the differentiation rule? Yeah. Then we need to take the derivative of the whatever function is in this, right, inside.
Yes, sir.
So this would be 3 by 2, and this is x square plus a square half, and differentiation of this is 2x. Right. So this is the 2 cancels, and we have 3x x square plus a square half. Right, guys. So this is b dash. Now just plug in these values in there. So kq and u dash is where is u dash? 1. B is how much? So x square plus a square 3 by 2 and then minus of u and v dash. So 3x and then x square plus a square half. Right, and divided by v is so x square plus a square cube. Right, guys? Okay. Yes, guys. So we need to put this value to how much? Okay. Am I audible? Yes. So we need to put this value to how much, guys? 0, right?
0, sir.
Right. So and this is this. Right. So this is 0. So this guy goes over there and becomes 0. This is also 0. We have this x square plus a square and 3 by 2 minus of 3x square and x square plus a square half, which is 0. Right. So we can take common here. So this would be x half common. And this would be no x half. So this would be so x square plus a square half prime. Right. So this would be how much? And this is minus of 3x square. Yes, everyone. Hello, hello.
Yes.
Yeah, so please respond, guys, right? Please respond. If you guys don't respond, then I think that you guys are not understanding. Right. So please be confident with your answer and please respond. Whatever is the answer, wrong or right, just don't care. Right. So please be interactive so that I can understand that you guys are listening carefully. Okay. So this guy goes in here and becomes 0, right? And we have this x square plus a square minus 3x square is 0. So this is a square and minus 2x square is 0. So 2x square is a square. And we have x square is root of a square by 2. Right. So what would be this value, guys? What would be this value, guys? So this would be plus minus a by right. Yes. So we have
plus.
Yes.
Here we have to take the distance of x as a plus a by root 2.
Right. So plus minus would be the two solutions of this root, right?
Yes, sir.
So let us go back to this graph, right? So at this point, x, so x equals to a by root 2. So this value will give the maximum electric field, right? And this is x equals to minus a by root. Okay, guys. So this will give the minimum electric field. So you can see that this is very close to this. So you can see that this is the ring charge, and this was the radius of that ring charge. So this distance would be is very close, or this is less than this a value, right? So this is less than this value. Understood, guys?
Yes, sir.
Okay, so we have found out the values of these x, and now we have to find the values of what is the maximum and the minimum electric field. Right. So E max would be how much? K Q X max divided by x max square plus a square by 3 by 2. Right, guys? So this would be KQA by root 2, and then this is a square by 2 plus a square, and then this is 3 by 2. So this would be KQA by root 2, and then this is 3a square by 2 power 3 by 2. Right. So what is 3 to the power 3 by 2? Yes, guys. Yes, guys, what would be 3 to the power 3 by 2? Right. So let us write this as 3 power 1 by 2 power 3. So this is root 3 cube, which means that root 3 into root 3 into root 3. So this is 3 root 3. Clear, guys?
Yes, sir.
Similarly for this too. So this goes in the denominator. So this would be KQA, and this is 2 root 2, just like this 3, and this is root 2. This is 3 root 3, and what would be a square 3 by 2? What would be that? So this 2 cancels, and we have C. Right, guys? So this is a cube. So a cancels, and we have k cube, and this root 2 also cancels. So root 2k cube by 3 root 3 a square. This is the maximum electric field for the ring charge. Understood, guys? Minimum would be just the minus of this. Okay. Yeah, yes, yes, yes. Yes, 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 Trevor. Thank you. Yeah, so where any doubt in this, guys? Yes?
This is the maximum electric field.
Yeah. So this maximum electric field would be here. So you see the graph, right? This shows that this is the maximum value, right?
Sir.
So this is whatever we have found. Right? What is that value? So just write that value. Okay. So this was all about this electric field due to the ring charge. You guys please note down this part. So where should I put the screen? Any doubt in this, guys?
Sir, here maxima, right? So it should be less than 0, right? The electric field.
No. So this is the maximum value of the electric field. We are calculating the maximum value of the function. We are not calculating the double derivative, right? So we didn't calculate this.
Okay, okay. Sir.
Right. So this would be, yes, of course, this would be negative for the maximum. But from the graph, we can see that, right? From the graph, we can see that this value is the maximum value. We know the graph, right? So when we didn't know the graph, then we would have done this, then we would have applied this method. Okay, Shabit. But we know the graph, and we know that this is the maximum value, this is the maximum minimum value. So if the graph is like this, let's say this is the graph. So we know that this is the maximum value, this is the maximum value. These are the two minimum values, right? So from the graph, we know that. So we don't need to calculate this double derivative, right? Understood, Chavez?
Yes, sir.
Yeah. So any more doubt? Rest of the guys, any doubt? Please don't, again, I will repeat that many times. So don't keep the doubt to yourself. Okay. Yeah. So where should I put the screen? Is this okay, guys?
Little bit down.
Yeah. So little bit down. Is this okay?
Yes, sir.
What about the rest of the guys? So are you guys noting this now? So today, yes, today I didn't solve any question, but okay. So for you guys, let us do one problem and then we will derive this linear charge test. Yes, Tarif sir, any doubt? Tarif, are you there? Okay, so you guys are not getting bored, right? But because what can I say? These are the calculations that we have to do, right?
Sir.
Okay, so should I scroll down this part?
Yes, sir.
Sir, we can't cancel x square plus a square.
X square plus a square from where? From where?
Yes, sir.
This part.
Yes, sir.
So you are saying that from the
No,
numerator
sir. Below one. Like
below
wouldn't
one.
we take it like
Why did we? Yeah. So why did we remove this part? Are you asking that?
yes, sir.
So this guy goes over here. So 0 into something, right? 0 into this 0 into this x square plus a, whatever is this. So this would be what? 0, right?
Yes, sir.
So that is why we just took this guy and we placed this in. Okay.
Okay, sir.
Okay. So should I scroll down the screen? Yes, guys, noted.
Yes, sir. Not.
Sir.
Yeah. Yes. Madhya, you are not writing in the chat box and you're not replying. In the earlier classes, you used to reply, right? But you have stopped. Any confusion or anything you want to say? Any suggestion that you want to make? Okay, so just to cheer you guys, let us do a simple question. Okay, and then we'll do the next one.
Yes, sir.
Done. Yes, Tariq, Mania, and Faisal. Done. Okay. Yes, so now let us do a small problem of the electric field and due to 4 charges. So just to freshen your mind on this. So let's say this is a square. And if Amna ma'am has already done this problem, then I am fine. Okay, so this is plus E, this is plus 2e, this is minus e, and this is minus e. So this is the square with the sides. Okay, and from the property of the squares. So what is the property of the diagonal of the square? What is the, yeah. Yes, one part is that the diagonals are equal and answer. They bisect at right, yes. So they bisect at the right angle. So all these sides are equal, right? And this angle, these angles are 90. Right, so this is the property of the square. Do you guys remember? As a Chavez told, right? So now these are the four charges, and this is 2E, and we have to calculate the electric field at this point. So this is a simple question, right? So we need to calculate the electric field at this point. Okay. Understood, guys?
Yes, sir.
So before I do that, did Amna ma'am did this problem? Guys, any of you guys remember?
Yes, sir. Something like this, sir.
Something like this. Or this question only.
Like on this point, electric field, yes, sir.
Something similar, but not this question.
Okay. So let us, so just to freshen you guys, right? We don't want to rush that electric field to that line chart. So just make your move, guys, because you guys are getting bored. So let's just try this question. Okay. So yes. So she gave Q instead of P here. Okay. Yeah. And was it minus Q or plus 2Q or minus Q and minus 2Q? Was that the question? Okay, so let's forget that and let's do this problem. Right. So let's repeat that. Yeah, so due to this, the electric field will be in this direction, right? So this is, let's say this is point A, B, C, and D. Right. So due to this charge, the electric field would be in this direction. So this is E. And due to this minus E charge, so this is negative. So electric field again would be in this direction. Right. So this is E. And due to this B point, due to this plus 2E charge, this would be EB. Right. And then due to this minus 2E charge, so this will be attractive. So this would be EB. Right. So we have these kind of effective diagram. And remember, these are perpendicular. Okay. So this is EB. This is ED, this is EA, and this is EC. Okay. So four charges, 4 people, right? Madhya, Chavez, Taiga, and Tari. So each of you guys will tell me what is. So let's start with. Okay, before we do that, so what is the diagonal of this this system? What is the diagonal of this kind? Or this square. So this is A, this is A, this is yeah. So this is A square plus A square, which means root 2A. Right, guys? So this would be half of that because the square bisect these diagonals, right? So this would be root 2A by 2. This is again root 2A by 2. Again,
A will be KQ by A, right?
EA.
The point A will be KQ by A. Right?
Point A. Why point A would be? Point A is point, right? So we can
Yes.
denote this point by P, P, Q, or A or B, right? So we are just denoting this point. KQ by A is the dimension of the potential, right? Potential. And where we have this minus K. So KQ minus KQ by A is the potential, right?
Yes, sir.
So yeah, so let's focus on this electric charge, right? Forget about this potential. So you are learning potential in MAM class, right? Yeah. So what is EA? Sorry.
Minus KQ by A.
Minus KQ. So whenever we calculate the magnitude, we don't care the sign, right? Because we incorporated those sign in here, right? In this direction, we incorporated those sign. Because of the negative sign, the force was attractive. Because of this positive sign, the electric field was this direction. So we already incorporated that negative sign. So if we again write negative, so that will be the opposite. Okay, so EA is K, Q, and what is the separation? Separation is this. Right, Tariq?
Yes, sir. Root 2A.
Yeah, so root 2A by 2 square. Ah, why I'm writing Q? So, right, Tariq?
Yes, sir.
So this would be this is 4, so this would be 4K by 2A square. So this is 2KE by A square. Right. Yes, Chavez, a very difficult question for you. What is EC? Let's write, yeah, so EC. Yes, Chavez, what is EC due to this point?
Minus KE, sorry, plus KE.
Yeah, so KE and
Uh, root 2A by 2 the whole square.
right. So this is, and this is again the same. So this is 2KE by A square. Right.
So,
Okay. Now, Madhya will tell me what is EB. What is EB, Madhya? So this is this is the separation, and you have this charge plus 2. So what is okay? So your mic, Faiza and Madhya mic is not working. So back to you guys. Tariq, what is EB? Sorry about that.
Yes, sir. Fine.
Yeah. So what is EB?
Maybe KE by root 2A by 2.
Yeah. So K2E by root 2A by 2 whole square. Right.
Yes, sir.
So this is 2KE by, this is how much? 2A square, and this goes over there. Cool. So this guy cancels, and we have 4KE by A square. This is E. Right. And the last guy, the sole person which is remaining, yes, Chavez. What is that? ED. Yes,
K into
same, right? Just try to do that.
plus
This will be
plus.
same. Right. So 4KE by A square. Right, Chavez?
Sir.
So now we know all these are magnitudes, right? So these are in the same direction. EA and EC are in the same direction. So EAC would be just EA plus EC. Right. So that would be 2KE by A square and 2KE, so 4KE by E square. Right, guys? And similarly for this case. So EBD would be, this would be EB plus EG. So this is how much? 448 KE square. Right, guys? So now we know the magnitude of two vectors. Again, we call the vector which I rigorously do, right? Rigorously do. So this is some vector A and this is some vector B, and they are perpendicular. So what would be the resultant? This would be simply A squared plus B squared. Right, guys? So the magnitude of this electric field would be simply EAC squared
So
plus
2AB cos theta, sir.
2B. What is theta, sir?
Okay, okay, sorry, yes.
Yes. Why sorry? Why sorry, Shah? Right. Yes. So yeah. So this would be BT square, right? So this is let's take K square common, right? So let's take it outside, and this would be simply 4 square plus 8 square, right? So this is K square, and this is 16 plus 64. So this would be simply how much? This is root 17. Okay, guys, so this is the magnitude of this electric field. So you guys, if you guys want to note down, please note this down, and then we will do this linear line charge electric field due to the line charge. So you guys want to note down this down. Yes, are you guys noting?
Yes, sir.
Anyone? Yeah. So guys, I am keeping the pace very slow, right? And in the middle, when you guys are familiar with everything, then I will just rush through all these things. Okay. So in the beginning, let's just keep our pace very slow and just understand all the things very carefully. Okay. So I think that in the next two classes, because in the next class, I will start the Gauss law, Flux and the Gauss law, and then I think that we'll be able to finish this chapter. Okay, and then yes, Tariq.
To the final answer, when I added 64 plus 16, it was 60. So can I just take it as 4 root 5 KE by S square?
Yes, 4 root 5.
4 root 5 KE by S square.
4 root by
4 root
5.
5.
5. So 4 root
Yes.
5 is 16 into 5. So this is 80, right? Root 80. This is 78. Oh, so this is 6 plus 4 is root 80. Sorry, guys. Sorry.
Yes, sir.
Mistake. Yes. So this is root 80. Yeah. So this is 4 root 5 and KE by A square. Yes. Calculation mistake, boss. Sorry. Yeah. So noted, everybody. Yes, Chavez, sorry, all done, right? So let us quickly do this. Yes, Madhya, you can write it in the chat box. Did you note down?
I did.
Yeah. Madhya, what about you? You are so silent. Everything okay? Okay, yes, I will assume then Yeah, so the next thing is that we have to calculate this. So from Gauss law, we know, right? From the Gauss law that, let's say, this is some cylindrical Gaussian surface, and when we calculated this line charged, the electric field due to this infinite wire. So the electric field came out to be 2 pi epsilon naught this radius r. Right. So this we know from the Gauss law, but we will learn this in the Gauss law. Right. Now we have to calculate this electric field due to this finite line charge. Right. So let's say this is some electric field, and let's say this is
Finite, can you repeat, sir?
yes.
Finite rod.
Yeah, this is the finite line charge, right?
Yes.
Okay. So this is, let's say this is theta, just for this case. Okay. We will write those different angles in there. So let's say this distance is L. This distance is, let's say, R naught. And let's say this distance as R. Okay. So let's say this, let's consider this small charge. Right. So here this small charge is some linear density. Right. And what is this linear density? Lambda is dq by dl. Right, guys? So this dq would be lambda dl. Right, guys?
Yes, sir.
So this will be, so this is theta, right? And this is dE. And this is, let's say, dEx. And this is dEy. Okay. So, and this is R naught and this is R. So what would be, what is the electric field dE? This is K dq by what is this separation? R square. Right, guys?
Sir.
So, yeah. So we can write this as K, and this is lambda, this is dl, and this is R square. So R square, we can write it as this value, whatever is this fixed value. So this is R naught, this is R naught, and this is R, and so let us draw this equivalent triangle. So this is R, this is theta, this is R. Right. So what is cos theta here? What is cos theta? Let me.
I'm not VR.
Yes, guys. Yeah. So you say what? R naught by R, right? So R is how much? R naught by cos theta. Right, guys? So this would be R naught square, and this is cos square theta. Okay. Clear up to this point, guys.
Yes, sir.
So now we need to take care of this DL guy. So because we know that this is theta here, so this is R naught square. And we know that, again, let us draw this diagram. So this is theta, this is R naught, this is L. Right, this R naught is fixed because we know this part. Right. So let's say what is this? So this is perpendicular, this is base. So what would be R tan theta? This would be L by R naught. So L is R naught tan theta. Okay, guys. So DL would be R naught, and tan theta, D tan theta would be how much? Sec square theta, d theta. Okay. Understood, guys?
Yes, sir.
So we can replace this dl by k lambda r naught sec square theta d theta and cos square theta divided by this r naught square. Okay. So this r naught, this cancels. And what is sec square theta into cos square theta? What is sine theta y into 1 by sine theta? This is 1. So cos theta into sec theta is 1 by cos theta, right? So this is 1. So this guy together cancels, and we have this k lambda d theta by r. Right, this is E. Any question up to this point? Yes, guys, any question up to this point? Guys, hello, any question?
No, sir.
Yeah. So let us go back to this this diagram. Right. So let me draw this diagram in here. So this is the diagram. This is DE. This is theta. This is DEY. This is DEX. So what would be DEX, guys? What would be DEX?
DE cos.
Yeah, so DE cos theta. And this DEY would be DE sin theta. Right, guys? So now we will separately calculate this EX and EY. Okay. So let us do that. And we know what is DE. So DEX would be k lambda d theta by r naught and cos theta. So this would be cos theta. Let me write it like this. So this is k lambda by r naught cos theta d theta. Okay.
Your
Yes.
DE will be 0, right?
D by
DEY, the component should be 0, right?
dy. Why? No, because we don't. Let me go ahead at some moment, and then you will see whether it is 0 or whether it is right. So yeah, so partially you are correct. For some case it will be 0, but for other case, yeah. So let us see that. Okay. Okay, Chavez. So DEY again would be k lambda cos theta d theta by so this is sin theta, right? Okay, so this is DEY. Now to calculate the EX and EY, what should we do? What should we do, guys? Yes, Tarif, what should we do?
Yes, sir.
So to calculate EX, what should we do?
Derivative.
Integrate, right? Take the
Sir.
integration. So let us integrate. Okay. So DEX would be EX. I am writing it directly, so I have integrated. And this would be integration of k lambda and by r naught cos theta d theta. So this we are integrating with respect to this theta. Okay, and similarly your EY would be k lambda r naught sine theta d theta. Okay. So let's just take one case. Let's just take that the wires are infinitely long, right? So let's say that wires are infinitely long, which means that this goes. So what would be this theta here? These theta and theta, these two theta, what would be that? So let's say that these wire are infinity and you are, so this is 1 theta, right? And this is increasing. So this would be at infinity, this would be what, guys? At infinity, this would be
Right.
pi by 2, right? And again, for this infinity, that would be minus pi by, right? Understood, guys? So for infinite wire, we are checking that for infinite wire, we calculate this as 2 pi epsilon naught. And this we know. From your CBSE course, you guys know this, right? So we want to check whether this result is the same. So for the infinite wire, we have this minus pi by 2 to pi by 2 limit. And this is pi by 2 minus pi by 2. Right. So what is the integral of this odd and even function? So this is odd function, this is even function. Right. So what happens when you have this, let's say minus a here, and this function is odd? So what happens? Right, guys?
Closed.
And let's say if for even function, this becomes 2 into 0, 3. Right, guys? Do you want me to write or do you guys know that? Any doubt? If you have any doubt, you can ask. Yeah, Chavez understood. Anybody else? You guys have any doubt?
So you can
Cost,
just once
yeah.
again use it minus pi by 2 to pi by 2 ex.
Yeah, so you want me to prove the limit or the integration?
So just how we are integrating it minus pi by 2 to pi by 2.
So let me write that integral value. So we don't want to use this analogy. Okay, so then let us integrate and then check. Okay, so this is k lambda by r naught, and integral of cos theta is a sine theta, right? And we have to put pi by 2 and minus pi by 2. Okay, guys. Understood. So this would be k lambda, and this is r naught, and this is sine pi by 2 minus of sine minus pi by 2. So minus of sine theta is what? Oh, sine of minus theta is what? Minus of sine theta, right?
So
Right, guys? Yes, yes.
Yes, sir.
Yeah. So sine pi by 2 is 1. And this is R naught, and this is, okay, so did I miss anything? Why I am getting, so this is 1 and plus 1, so this is 2k lambda by R naught, right? Understood, guys?
yes,
So this would be 2 into lambda by 4 pi epsilon naught R naught. So this guy cancels and we have the result that you guys already. Right, so this is the result. Right, guys? What about this one? So let us try to calculate this. So this would be k lambda r naught, and this is minus of cos theta. So minus of cos theta and pi by 2 minus pi by 2. So this will become k lambda r naught cos pi by 2 and minus of cos of minus pi by 2. And what is cos of minus theta, guys? What is that? Yes,
pi,
Tarif. Yes?
pi minus cos
No, this is cos theta, right?
minus cos theta.
Not the minus. So this is cos theta. Okay. You remember. So let's say that this is minus theta, right? And you want to calculate what is cos of minus theta. So b by h, right? Okay, and this is let's say this is cos theta. So for minus theta, this is B, right? And this is H. Right. So you see that this is positive.
Yes, sir.
Right. Yeah. So this is positive, B bias, so this would be positive. So this is exactly like this cos theta. Right. But for P by H case, this P is negative. Right. So your sine theta, sine of minus theta is minus of sine. Understood? Now you understand. Should I explain this again? Chavez and all.
The derivative of cos is minus sine, right?
Yeah, we are not taking the derivative, right? We are saying that what is cos of minus pi by 2. Right. Understood. So yeah. And you can also see that this is cos pi by 2. So this is 0 and this is 0. So you will get 0. Okay. So for sorry guys, I took the extra time. So the rest part for the finite wire, what we will do is that, so in the next class, I will quickly do this. So the integral limit will just change. So this will be minus theta 1 and this will be theta 2. So we'll find that your Ex would be whatever this lambda 4 pi epsilon naught R naught, and this you will see that this is cos theta 1 plus sine theta 1 plus. So this would be sine theta 1 plus sine theta 2. So you will find that. Okay, and for the EY part, you will see that this is lambda by 4 pi pi, and this is cos theta 1 minus cos theta. Okay, so this you will see in the next class. Okay. This is for the finite wire. So Chavez, you see that this is the Y component of the electric field. Right, Chavez?
Yes, sir.
So when you have this finite wire, then you have the some magnitude or some value of EY. But when you have this infinite wire, then this magnitude is 0. So where should I put the screen? Do you guys want to note down, or you want to note down in the next class? What do you guys want to do?
In the next class.
In the next class. Okay. Yes, Shave. So yes, guys, we will note down this in the next class. And if you guys have any question, then we will discuss this. So if you guys face, today I was not able to give you guys any homework. Yes, Chavez, can you tell me, did Amna ma'am do this problem in the CBSE course?
No, sir.
This?
Only Gaussians surface sheet you can derive.
Okay. Okay, so she used the Gauss law, right? For the infinite wire.
Yes.
Okay. So guys, we will note down this part in the next class, and if anyone has any doubt, please ask, and I'm here to answer. Right, Faiza, Madhya, if you guys have any question. So I will repeat that in the next class if you guys find it. Right. Ultimately, we have to know the formula. What is the formula for this finite? But I just wanted to tell you guys how we reach that. Okay.